Hello everybody, this is Solar Tiger with a solar power video. Today is the 2nd of August and it is lightly raining outside, but this is a video to show you how my solar system is put together. Okay, out here we have the 3 100 watt solar panels. These are the monocrystalline panels. You can tell this from the square cells with the corners cut off. These are the monocrystalline panels. Monocrystalline panels are the most efficient, but also the most expensive. You can also get polycrystalline panels. Their cells are square, but with the corners on. So I have 3 panels wired in series, and they are on a ground mount. You can also put your panels up on a roof, such as on your shed, but I find that my panels are easier to clean on the ground mount. So as you can see, I can walk up to them and clean them. If I show you a close-up of the cells, you see they are square with the corners cut out. These are monocrystalline. These panels cost about 80 to 90 pounds each, and that's how these panels are. They are on a homemade stand. This is made out of timber fence posts, but you can make yours out of metal or plastic or whatever you can find. The panels come with leads fitted. The leads, this is outdoor solar PV cable. The cable connected to the panels is 2.5mm squared, though for any longer runs I would use the 4mm squared cable, and they have waterproof connectors on. These connectors are called MC4. I believe it stands for multi-contact 4. These just clip together and are fully waterproof for outdoor use. So on the back of the panels is a junction box, and this is waterproof as well. The wires are normally pre-fitted to your panels, and the panels come with a 25-year warranty, but if you remove the connectors, in most cases it voids the warranty. So if I show you a label on the back of the solar panels, I'll turn you around this way. Now on the label you'll find certain information, such as the model number, the rated power. These are 100 watt panels. You'll find a maximum power current, which is 5.8 amps here, and a maximum power voltage of 17.2 volts. There's a short circuit current of 6.46 amps and an open circuit voltage of 21.6 volts. And there is the weight of the panel in kilograms. Now this can be important if you have to carry these panels up a ladder. You might consider that buying 2 smaller panels is better than trying to lug one very heavy panel up a ladder, which can lead to accidents. So that is that. The short circuit current is a thing that you should note when selecting your charge controller. The maximum current of your charge controller should be more than the short circuit current of your solar panels. In this case, these panels are wired in series, so you should get 17.2 volts times 3, whatever that comes to, but I can tell you from experience that that exceeds over 60 volts in this case. So on a good sunny day, you can easily get 60 volts out of these 3 panels in series. I wire my panels in series because I am using an MPPT charge controller. That stands for Maximum Power Point Tracking, and basically it can convert the high voltage from the solar panels down to the correct voltage to charge the batteries. There are cheaper charge controllers on the market called PWM, that stands for Pulse Width Modulation, but they cannot convert the high voltage down to the voltage of the batteries. In that case, if I was using a 12 volt controller, I would wire these panels in parallel. So the output voltage would be 17.2 volts, but the current would be multiplied by 3. Now, I would recommend to use an MPPT controller, as they are not that expensive now, but they are much more efficient, and this means that you can use a thinner cable to connect your panels to the charge controller. For any given power, if you can use a higher voltage, then you will need a lower current, and the thickness of the wire that you need is governed by the current. Also, losses in the cable increase with the current, so better to use a high voltage and a low current, which means you can use thinner and cheaper cable, because when you connect your panels over to your charge controller, then you can use thinner cable. Thinner cable is cheaper and easier to work with. I will show you that I also have a wind turbine. This is a Rutland 913 wind turbine. The blades are approximately 3 foot in diameter, and I have managed to get 100 watts out of this, but it was blowing very strong. It was a storm. But with wind turbines, I would only really recommend them if you have a constant supply of wind and you live somewhere out in the open. If you live in a housing estate like I do, I probably wouldn't bother with the wind turbine, and they are expensive. This one was second hand and it cost almost £300, so I would probably just stick with the solar panels. So this is the outside part. If you live somewhere where you're prone to thunderstorms, then it's recommended that you connect the frames of your solar panels to a grounding rod. It just minimises the risk of electrical surge getting into your system. Also, while I am out here, I am going to show you something else. You'll see the reason why later. Upstairs, you can see where the cable goes into the house. You also see that thin yellow and green wire. That is an earth cable, and I will tell you more about that later. But you'll see that that is run down behind the great bushes, down to a grounding rod. This is important when using a power inverter, as for safety reasons you need a earth. An earth will then make any circuit breakers or RCDs that you use trip or blow any fuse if you have a mains voltage fault in your AC wiring. I'm showing you this now because I'm outside, and in part 2 I will tell you all about what I have inside. So see you in the next part.